Whoa, I thought you said you were going on a diet. Well, it's just one. It can't be that bad. Oh, who am I kidding? I can never stick to my diet. What Milo went through here is called cognitive dissonance. This is when an individual has two inconsistent beliefs which cause discomfort. You see, our bodies are constantly striving for harmony. We don't want to believe in eating healthy, but then go out and eat donuts because it's inconsistent. People attempt to fix this discomfort by rationalizing their actions. In the case of Milo, he changed his thought and trivialized that donuts are actually not that bad. You may be wondering how cognitive dissonance originated in the first place. In 1957, a man named Leon Festinger outlined a detailed description on how humans aim to balance their psychological thoughts with their actions. Festinger argued that combining actions which are contradictory to thoughts induces stress. As a result, some resort to blindly believing anything to help ease their tension. Functional MRI imaging has allowed researchers to detect changes in brain function and link them to cognitive dissonance. The medial prefrontal cortex has been identified as a critical component in avoiding unpleasant outcomes. It is known as the brain center as it makes decisions after evaluating senses such as touch and sight. fMRI imaging has shown that when a subject lies to a peer while knowing that lying is morally wrong, an inconsistency, the MFPC becomes activated. Researchers were able to link the prefrontal cortex and cognitive dissonance through transcranial magnetic stimulation test. This technique consists of limiting activity in the prefrontal cortex, which helps to lessen the unpleasant feelings caused by cognitive dissonance. It directly verifies that the medial prefrontal cortex plays a critical role in causing emotions such as guilt during dissonance. Some scientists used TMS and found that zapping the dorsolateral prefrontal cortex with electrodes can disrupt its activity and lessen the amount we try to rationalize our beliefs following cognitive dissonance. Our behaviors do not result from a single region in the brain. Instead, it has been found that regions such as the insula and DLFPC are also engaged in cognitive dissonance. The insula is responsible for processing emotion and becomes activated when people are upset or angry, while the DLFPC is correlated with cognitive control. Let's simplify what we have learned so far into an example. Working out. You may fall asleep at night and tell yourself you'll work out in the morning. You wake up and put off the thought of working out until later because you had a healthy meal last night, so it doesn't really matter if you work out. Your prefrontal cortex kicked in here as you attempted to rationalize your laziness. You go on about your day, and your friend makes you eat a high-calorie meal to which you realize you have miserably failed at your goal, and you begin to feel guilt. Your insula becomes activated here as you face the emotional aspects of dissonance. Common rationalizations you have likely heard of are, everyone else does it, no one will know, I know I shouldn't do this, but it's for the greater good. These things happen. Watch out for these and use them as warnings to avoid harmful behaviors linked to cognitive dissonance.